4.2.1. This is day 3. We are on one more last problem here, 4-61. And it's a familiar problem. It is the problem we did on day 1 with the absolute value. And they want to go about it a different way, Bert and Ernie. So let's go back and look at 4-59 for a second. And you'll see here, we had to find the boundary points. So we solved this algebraically. We added the 2 over, we divided by 4, we split the equation into equals 2 and negative 2, and we found 1 and negative 3. And you can certainly do that, but as you've known this whole chapter, there's multiple ways to do things. So what he's saying is, why do we have to solve it algebraically? Can we find these boundary points on the graph? So we're going to go ahead and do that. We're going to take this equation. Well, we're going to make it an equation, right? And we're going to put the left side in and the right side in, and we're going to see where they intersect. Okay, so I already have it on my calculator, and I will pull up my screen. It's going to take some maneuvering here, so hang on here. Let me pull my camera up. Okay, so I have the left side and the right side on my screen. Now, if you want to know where I got the absolute value bars, let me just kind of go down here to a blank area. When I type in the 4, I type in a 4, right? And to get the absolute value bars, you're going to hit the word math. It's under the green alpha. And then move up to number, or move over to number. And then ABS is the first one. So when you hit enter on it, you'll get a blinking cursor inside absolute value bars. Okay? I'm going to clear that, and here we are going to graph these two. And there it is. We've got the absolute value graph, and we've got the 6, the constant line. And we need to know where they intersect. Well, we already found them graphically or algebraically, but again, alpha, not alpha, second, and then calculate. And now we've got to tell it I want this intersection, so just go near it and hit enter 3 times. And we've got negative 3. If I do it again, second, trace 5, move over here, and I bet this is going to be our 1. Move it close to it, and it's our 1. So negative 3 and 1, and we did not have to do any algebra for that. Okay, so that's what he wanted. We can graph it. We don't need to show the graph, but we've got x equals negative 3, x equals positive 1. Let me move that out of the way. They wanted to know what should they graph. Well, we're graphing for x plus 1 minus 2. And then on line 2, we're graphing y equals 6. Okay? So we graphed it. Again, we do not need to show the graph. I had it on my graphing calculator. And now you go right to those sections on a number line. And we're looking at open circles here, because it was a greater than. And then we're looking at sections A, B, and C, and do that accordingly. I'm not going to do it again. We already did it up top in 4-58 or 4-59. So if we go back up to there, we found that section A and C were the ones that work. So I'm actually going to copy this whole thing, I believe. Let's see if I can do that. I'm going to copy that whole thing, and I'll just write it right down here since it's the same. Paste image. We can get rid of all of this. Actually, let's get rid of all of this again, and we'll paste the image. And there you go. We have it all right here from before. Okay, so again, it's just a different way. So you can solve it algebraically, or you can use the graphing calculator. We're looking for the intersecting points. Okay, we'll have a review coming up, as well as a quiz on Wednesday.